Now let's see the case where we calculate the mixture of weak base. We have to calculate the pH of mixture of weak bases. Let's say we have base 1 HB1 and we have another base 2 HB2. The Ka1, the Kb1 is given, the Kc1 is given, the Kb2 is given, the C2 is given. On the OH negative, we have derived in case of strong mixture of weak acids like H plus coming out to be a root of Ka1C1. Here the root of Kb1C1 plus Kb2C2. Now we have a problem over here. In that problem, it is saying that calculate the pH of solution containing mixture of, we have one base, let's say it is B1OH. Its Kb is given, its C is given, and here we have a solution. If we write the Kb and C both the value, so Kb is 10 raised to power negative of 7, and the concentration is 0.4 molar and volume is 500 ml. Now here we are mixing with another B2OH and Kb is 4 into 10 to the power minus 7 and concentration is 0.8 by 3 molar and volume is 1500 ml. Now we are mixing both of them. The volume final is actually 2000 ml. And here we have B1OH and B2OH. Now we have calculated the pH of this solution, right? Now we know the concentration of OH negative, we have seen. Just the mixing formula is over the root of Kb1C1 plus Kb2C2 that we have seen. Now can we use them directly? We have seen C1, the volume is given initially and final volume is given. Kb value is given. So could we use that concentration? No, actually this concentration was the initial container. In the final concentration was the concentration we have to calculate for B1 and B2OH separately. Like if we talk about the B1OH, the concentration of B1OH in the larger container, we know the moles of BOH is remain constant. So initially it was moles with M1V1. So the initial concentration was 0.4 molar and the volume was 500 ml. Now let's say concentration has changed to M2 and the volume is to 2000 ml. So M2 comes out to be 0.1. Now final molarity is 0.1. If we talk about B2OH, initial it was 0.8 by 3 and volume V1 is 1500. Now M2 is the final volume and the final molarity and concentration of the volume was 2000. So M2 equals to 0.2. So concentration of OH negative was, as now we can use that formula because the molarity has changed. So Kb1 M1 into Kb2 M2. So Kb1 is 10 to the power minus 7. M1 is 10 to the power minus 1. And Kb2 is 4 into 10 to the power minus 7. And Kb2 is 0.2. So that is actually, if you add both of them, it comes 9 into 10 to the power minus 8. So actually it is 3 into 10 to the power minus 4. Now POH is negative log of 3 into 10 to the power minus 4. So it is 4 minus log 3. So 4 minus 0. Log 3 is 48. So it is 5.52. And pH turns out to be 10. pH if you see it is 14 minus 5.52. So pH actually was 14 minus POH. So 14 minus 5.52 is 10.48.